Precalc 3.3, this is day 3, finishing this up, just kind of putting together the fact that we went through all this trouble of making a list and checking it twice to make sure that we find out what works and what doesn't work. And it takes a long time. But we all have at our fingertips a really powerful thing, and that's a graphing device. So you can use Desmos, your graphing calculator will work, things like that. And so what we can do is graph the equation in question. If you graph the equation in question, you will then be able to have a better idea of where it's touching or crossing the x-axis. And then you can set your window by using the upper and lower bound theorems. So we're going to still make that list, guys, to help us out. So if I was looking at this particular problem, I would say, hey, I have 1 and 3, 1 and 3, because the factors of 3 at the end, factors of 3 in the beginning, that is a 3. There's a 3x to the 4th. It's hard to see on the screen up there. And so you get 1, you get 3, you get 1/3, and then back to 3 divided by 3, which is 1. So you get only 6 options. Well, even at this, guys, that means all of your zeros have to lie between what 2 numbers? Just by looking at that list. Not 1 and 3. -3 and 3. Because remember, we're plus or minus of all of these. So even at that, if we were to switch to Desmos and we graph this, which I'll do, I'm going to pause the video, we can change things. So we have it graphed, and we changed our domain to be from -3 to 3 because that's what our list only includes. Could I make this even better yet by starting to check, using synthetic division, some of those numbers? Maybe, since we're using Desmos, it's not necessarily needed, but we're also allowed to click on the graph and actually see what those points are. How could I use this graph to say, I think I know what the actual solution is? We have options of 1, 3, and 1/3. Well, first of all, if I was to test any of those, would they work? Would any of those work? Do any of them cross at 1, 3, or 1/3, plus or minus? No, they don't. But I do see an answer about at negative what? 2.3 and 1.3. It's almost like -2 and 1/3 and 1 and 1/3, or 4/3. So that's what it appears to be, but that's not even part of my list. Why? That's kind of weird. So maybe it's not actually 1 and 1/3, or does it come out to be nice like that? I don't have Desmos up here by me. If I clicked on the dots, now I'm recording this because I can't see this, you actually get -2.303, and you get 1.303. We don't know what the rest of those dots are, right? So therefore, I can almost probably safely assume that has to do with some kind of square root. Which means you wouldn't be able to make that with your list. We only find rational zeros, not irrational zeros, making that list. But if I would have chose 3, and I'm going to go back to the dossary, and I want to just show you how this upper and lower bounds are going to help us. Obviously, we're looking at the screen. Using the computer app, we can click on them. We now know our zeros. That's awesome. But if I needed to figure out where those zeros were on my graph, because maybe I'm using a graphing calculator, which is not as easy to move around, then maybe I want to use the fact that I'm seeing points that are crossing at those places, right? We thought by just looking at it was negative 2 1/3, but it really came out to negative 2.303 la-di-da-di-da. Maybe we should test with our synthetic division. Maybe we should say, hey, I got 3, negative 7, negative 2, negative 3. What happens when I put a 3 in? I'm not even going to put 3 in. What if I put 2 in? Will 2 work? 2's not going to work. But what do you think is going to result on the bottom here, across the bottom? What will be there? It won't be the positive negative ones, but it will be all positive. I forgot the 4?
Yeah.
Oh, thank you. It's 3, 4, 7, negative 7, negative 2, and negative 3. We should result in all positive numbers. So 2 times 3 is 6, which leads us to a 10, which leads us to a 20, 13, 26, 24, 48, 45. They're all positives. So even at this, 2 is an upper bound, right? So guess what, guys? If I went back to Desmos, instead of going all the way to 3, I could change my domain to go into 2. So every time, guys, that I am making a decision to test one of my answers, every time it gives me a new piece of information, I will change my parameters on my graph. Okay? Does that kind of help with the idea of maybe possibly using or finding your x-intercepts?
So how do you do that on a graph?
So if I went back to Desmos, I would change the upper bound. You're going to see the exact same graph. We're just going to change it. Instead of going to 3, we'll go to 2. Okay. So you go back up to there. Now, what I really want you guys to do is graph it and say, it crosses at these places. I know I'm going to check 1, I'm going to check negative 1, and I'm going to check 3. You now can take a 5th or 6th degree polynomial and very quickly find all the zeros, so therefore you can place it into synthetic division and show it. So not only did I want you to take the idea that we're going to be able to limit our domain by finding the upper and lower bounds, but I also wanted you to be able to graph it and then limit your list even more by saying, I know it has to be this one or it has to be that one. And the last example here is talking about a fuel tank that consists of a cylindrical center that has a 4-foot long section and 2 hemispherical end sections that technically, when you put together, make a full sphere, right? As shown below. If the tank has a volume of 100 feet cubed, what is the radius r shown in the figure? Up to the nearest 100th of a foot. So basically on these word problems, you're going to create an equation with your formula that you have to solve. So how do you find the volume of a cylinder? It was on your last quiz. Some people found volumes of cones. It's not 1/3. Volume of just the cylinder or the can is pi r squared h. Some people put a 1/3 in front of there. They found a cone or a pyramid. We're going to get those back hopefully tomorrow. And then we have to add the end caps. The end caps are a ball. Does anybody know off the top of their head? 4/3 pi r cubed. There's your formula. Do you know anything about any of those? We do. You know the volume is, and you know the height is 4 feet for the cylinder. Whoops, not a 4, but of h, but a 4. Plus 4/3 pi r cubed. Now I want you to solve this. To solve this, bring everything to one side. Notice that pi is a number. So 4 times pi is a coefficient. 4/3 pi is a coefficient. So if I do subtract the 100 over, and I reorder it, would you be okay with that switching of order? Minus the 100. You now have a cubic that you have to use Desmos for, or a graphing utility. Solve for R. Question is, there will be possibly answers that are negative for R. Will you choose those? No. So just put this on Desmos and find R. The hardest part about these problems, guys, is creating that, which leads you to the equation set equal to 0. The only way you can solve an equation is if you set it equal to 0, because you're solving what R values make it 0. So when you put this on Desmos, what do we get? R equals, Grace, you got one? 2.153 feet. Notice the question says to the nearest hundredth, so we should actually only say tenths, hundredths, 2.15 feet. So we just use the fact that I can just put it on Desmos. Desmos will do all the work for us. Homework's on page 289. Actually, it starts on 288. And then we'll say 70, 83 through 86. Have a great day.